because a lot of times students will pick up the wrong buffer. So there's no salt. That's what you use to actually equilibrate your column. And then you've got salt, okay? That's buffer with 0.5 molar salt on it, okay? Please write down the buffers and what they are and the pH and so forth, okay? All right. You'll also note that you have resin, okay? So to the question that the young lady was asking, I asked you if you said, in class, we said that there are two types of resins that we typically use. Okay, this circle here, what does this circle represent, Miss Simmons? It represents the resin. So that is the little white stuff that you see in that tube. And so the X here represents the functional group that you saw on your quiz. And in this case, that functional group is a positive, because it's been established at pH 7.25. And so this represents a anion exchange resin. And that's what you'll be using the D today, and it has a name, DEAE, which is the acronym for it, and so forth. Okay, all right. You'll also note that you've been given rat serum. Okay? You have to write down what the name is. Don't put unknown protein. Of course, I'm going to write in your lab notebook. Unknown what? Some of you probably have seen that. Unknown what? Unknown M. M what? Okay. Oh boy. All right, so you're going to have to set up your column, and essentially, you'll note that you have clamps. Okay, so I'm just going to set the column up here first, just to show you how to set it up there. And it's you know, as I said to you before. There we go. Okay, and this is the clamp. Okay, the clamp just prevents stuff from flowing out, because it's, you know, you want to put it in there. Okay, all right. And so let me go over here and point out what you're going to be doing. Okay, so let's take a little step one. Okay, so step one, okay, you can get through. Step one, you're actually going to pour your resin in your column. And you're going to do it carefully so that you don't create a whole bunch of bubbles in it, because at the molecular level, proteins don't like interacting with bubbles. Okay? So, here now you've got your little resin. Now you see when I was in class, I'm drawing something look like that. So here we got, you may have a plant there. And so in essence, the first thing I want you to do is to take and fill up your column with approximately no salt buffer. Okay? So no salt buffer, you're going to pour some of that in here. Okay, and it's very simple, straightforward, shouldn't take you long. Okay, I'm picking up and reading, and I'm going to take and pour this column, about half of it with no salt buffer there, like that. Okay, and that's going to allow my resin to just sort of float on down and settle. Okay, and you can see that I didn't tighten this. And now you know why you have what you have, napkins, so forth and so on. Okay, so make sure that it's tight. And of course, in this case here, I'll just clean myself up here a bit. Okay. What is what called? Yeah, it's called a clamp. Yeah. Yeah, you never used one in chemistry before, right? Right. It's our fault. Okay, our fault. Okay. There we are. Okay, so this beaker is to catch the waste. That's what that was actually there for. So let me just lower that a little bit. Okay. All right. Okay, so once you then do that, okay, you got your little beaker here, and that's going to catch the waste and so forth. Okay, and so now we're going to equilibrate the column. So in this particular case here, you know, here's your resin. Okay, you just want to rock it back and forth. Very simple. Okay? Rock it back and forth. You're mixing it. Okay. And you note that you got 3 of these little doohickeys here. These are plastic pipettes, okay? And so, again, before I even start, your protocol calls for you to take your marker, and I think it says to mark it 5 centimeters from the bottom. Well, I'm going to change that. Okay, Sam, I'm going to change the protocol. So when you read the protocol, I don't want to see 5 centimeters because we're modifying the protocol. That's what research is. So I'm going to mark this on the column. Okay, there we go. And I'm going to mark it, in this case, 6 centimeters. 6 centimeters from the bottom of the blue tip. Okay, there we go. Note here, I'm using test tubes that I can actually measure, okay, the inner diameter. It's actually on the box. Okay? I'm going to put the box in. Okay? Okay, test tubes aren't really just test tubes. So when you write in your lab notebooks, test tubes, which one are you referring to? Referring to this one? Or are you referring to this one? Or how about this one? Well, if a person's reading your lab notebook, they don't know what you're referring to because all you wrote was 15 test tubes. All right, so here's the box. It tells you the type of test tubes there, borosilicate glass test tubes. They are disposable, but we keep them. Okay? 13 millimeter inner diameter, 100 millimeter length. And I'll just put that there so you can see that. Okay, there we go. I'm just, I'm hoping that if you don't get into medical school, you get a job in your discipline where while you're preparing to go to medical school, you can actually be paid well. Okay, so now that that's there, I'm going to take one of these. You note that there's 3. One for your resin, one for your no salt buffer, one for your salt buffer. You don't want to mix them up. Okay, and I'm just going to pour the resin in there like that. See, you're getting a chance to see it. Okay. And you're following it on board. So we're going to pour, okay, and that's step 2. So there we go. Okay. And now that that's sort of filled and the water's sort of filled, then I can sort of just carefully take this and just sort of pour it on the side there like that. Okay. And I think that, and I'll let that settle. And I'll see how far that settles. Okay. All right, so now we're at step 2. Let me get my marker here. We're at step 2. So here's step 2. Okay, so step 2. You're going to essentially now equilibrate your resin. Equilibrate. Okay. And equilibrate means that you're going to essentially, once this packs, okay, you're going to then add approximately, I would say, about 100, I would say about 75 milliliters of no salt. Okay, so we're going to equilibrate. So here's the column. Okay, there we go. And I'll set you up in just a second. So here now you got your resin. It's in there. And we're going to essentially add about 75 milliliters of no salt. Okay. Buffer. And of course what that does now is it essentially sets up so that your column is ready to go. It's charged, okay? The buffer is at pH 7.4, that has a positive charge, okay? And now you're ready to go. Okay, so how do you determine that? Well, I'm going to show you in a minute. I forgot to put something at your bench. That's why we're in lab, okay?
So you pointed it in twice. So he's pointing it in twice. Because it says add no salt buffer when using parts. Ah, thank you. And I'm like, what are you talking about? No, but he did it in, remember in lecture when he first started talking about it? I remember how he did it in lecture. So hopefully I got a little something. I wonder what they might. I'm looking at my to see what it is. Yeah, I can try. It's not gonna be really long now.
Okay, see. There you go.
I tried.
There you go. There you are. There you go. There you go. Welcome. There you go. There you go. Okay, so we walk down here. There you go. There you are. There you go. There you are. There you go. One for you.
Thank you.
Okay. Okay, knew I forgot something. All right. Okay, so roughly there I can see my mark of 6. So what I can do now is I can just say, okay, I'll remove some of this guy here because it's roughly about 6. Doesn't have to be perfect. Okay. There we go. Okay, so now I'm going to equilibrate the column. Okay, and I'm going to do that, and I'll take no salt buffer. There we go. See, very simple, no salt buffer. Okay. And while that is equilibrating, I'm just going to take this guy and fill it up. Like so. And you know, it really only takes about, this is a small column, it only takes about maybe 50 to 75 milliliters really to equilibrate a column of this size. Okay. And of course, once I get it all the way up to the top, okay, then it's easier to just slowly add buffer to the top like that. It's easy to do that. And now I'm going to let this drip out, okay? And again, this is allowing all of the buffer to flow through. And of course, this is called the eluent, okay? And I'm packing my column, and at the same time, I'm equilibrating the column, okay? There we go.
Dr. Hall, what is the solution that the resin is in again? What is that called? It starts with an A, you said?
Say that again?
What is the solution that our resin is in?
Oh, it's actually in the same buffer that you have, no salt buffer.
Oh.
Okay, so you see there, and I can just pour it in there like that, okay? And, okay, there we go. Now you can see here, I can see that my resin has begun to pack. So now I can begin to add more of the resin. And again, I'll just, again, add it all, if need be, to get it up to 6, okay?
Wait, Doctor, how do you know when your resin has the
Because you're looking at it.
Okay.
Okay, you're looking at it. Okay. I can't pull her hair Bennett, okay? And so, again, in this sense, if it just requires all of your resin, then you just put all of your resin in there. So in this case, I put all of my resin in there. It's good. There we go.
So what are the things to make sure the resin is dripping at, like, where are we looking for?
Well, you're packing the column. You're packing the column with resin. No, the resin ain't coming out. What's coming out?
The buffer.
So your resin's in the column. Okay, I'll stop it and pass it around in a minute. Okay, even though you can see stuff, okay, when you've never done it before, okay, you're getting a chance to see it. Okay, so I'm going to put some more buffer in there like that. Okay. Now, after my column has packed, I'm going to pass it around to you so you can see where the resin is packed. Okay. And again, I got plenty of resin, so again, I'll stop this here, okay, for now, but I'm going to get some more resin there. I have some more here, and I have
I
plenty,
think so too.
so if you need more, you can always get more.
Yeah,
I'm
okay.
gonna pass it around in a minute. I'm gonna pass it around. I need more, so I have that column there, the height 6, not quite there yet. Okay. There we go. Okay. It's almost there. All right. All right. Okay, so in a minute I'm just gonna, see the bottom of the column has a little disc here, and the disc has pores that will allow water and proteins to flow through, but not the resin bead here. That's why the resin bead, this inert bead, is still in the column. Okay, all right, so almost there.
Dr. Hall,
Yes.
in the procedure when it says that the DE52 resin needs to be degassed, is that while you're putting
Already
it in
degassed for you.
Oh, okay.
Everything's been done. Why do you think everything's at your bench? Okay. But if you were going to do this in a research lab and you had DE52, okay, that you were going to use, you would want to degas it. Didn't you learn in organic chemistry how to degas something? You never learned how to degas something? Yeah, you should have in organic chemistry. I taught organic chemistry for 10 years.
I don't know about that, Dr. Hall.
Okay. All right. So there we go. Note so far, it's only been 15 minutes. Okay. There we go. I'll just pour more there. All right. So now I'm going to. All right. I'm almost there. Okay. So now I can essentially take some of this out here. Okay, because I'm at my mark of 6 centimeters. Okay, like that. And now I can just put buffer in there. Okay, so forth. Get a chance. What lab will you do where the professor comes in and shows you how to do the lab, and then says, okay, show me what you're working with. Okay, so let me go ahead and let this out. Okay. Bless you there. You must not eat lunch. Okay, so now I'm going to just take some of this buffer off here, and I'm just going to now pass my column around. Okay. So that you can see the mark. Pass it around. I did my column. Just gonna take a picture of it. Take a picture of it. Okay. Look at the mark. Okay. Just pass it around. Okay. Now, the primary reason most of you have this look on your face is because you really don't ever expect to be working in a lab. You really don't. Okay? In fact, some of you are so terrified that you don't know enough to even begin to look at a lab, more or less think about working in one. But for those of you who say, hey, I'm smart enough to get this, I can work in a lab, it's a little different. Okay? Because when you leave Norfolk State, people judge you based on your performance in a given environment. That's what they decide whether they're going to keep you or not. And most, like EVMS, when they hire somebody as a research assistant, they give them 90 days to see if they indeed can fit, if they've been trained well or not. But the first step is they ask you to make a buffer. And if you can't make a buffer with your 3.8, you don't get hired. Because nobody should be paying you $40,000, $50,000, $60,000 a year when you can't even make a buffer. And you're coming to them with a 3.8 GPA in chemistry or biology. So you see my marks, mark height 6. Okay. All right, look like I'm on cue here for a bit, passing around. Okay. Now, the sad part is that most of you are not told anything. You just go about your merry way. Nobody tells you, no, this is unacceptable. No, you can't have these kind of habits. No, you can't be turning things in late. No, you can't show up late. No, you can't say, oops. So people don't deal with that stuff in the real world. Okay? Oh, I'm going through some stuff. Everybody's going through stuff. Okay? My daughter's bipolar. I told her the first time, did you know that The Rock is bipolar? Did you know that Mariah Carey is bipolar? But when somebody pays you $20 million to do a film, you better get your psychiatrist together so you can take your meds on time. Or else you're going to be sued. So that's what I told my daughter. Okay? You're in a hospital working with patients. You don't get your stuff together, they fire you. And of course, she was fired. Why? She didn't take her meds. And she wound up doing goofy stuff. They said, you're putting patients at risk. So you fired. So then she lost a job that she had for 5 years. And of course, I don't take care of grown folk. I take care of children. I don't take care of grown folk. Go to a shelter. So that's where she is, at a shelter. All right, ladies and gents, so now that my column is equilibrated, okay? Column is equilibrated. Now, at this point in time, you can either stop here and say, I'm coming back tomorrow. I'm sick of listening to Dr. Hall's mouth this afternoon. I'm coming back tomorrow. Okay, well, you can stop there. This column is going to, then we go to the next step. As I told you, I'm going to go through the step. I'm going to put my sample on, and then I'm going to start collecting fractions so that you can see. All right, so once your column is equilibrated, you then, now what you want to do is you want to essentially remove as much of the buffer using your doohickey here so that your column resin, okay, there we go. Okay, so you go as close to that column resin as you can, and I'm going to show you that because I got time here before I have to take a little meeting there. Okay. Now note here, about 25 minutes has gone by. So I have poured a column, okay? I have equilibrated the column, and I'm about to now put my sample on the column, all within 25 minutes or so, okay? All right, so now you wanna, okay? And now you essentially open the stopcock, and you let that drip until your resin is wet. Not dry, but wet. Now, it's impossible for it to be dry unless you accidentally just leave it overnight, and it could be dry tomorrow, okay? All right, okay, so we're now at step 3. So here's step 3. Step 3, application of protein sample. Now I'm applying protein sample because I'm recording. Okay, so voila. Okay, so now I'm going to pass my column around to you again to show you what I have done so that you can see it, so that you won't have to say, Dr. Holt, how far, did I do it right? Okay, you get to see it. Okay? The column is wet. I've released enough buffer to let the column wet. Okay? Now, why do I do this? Because my expectation of you is greater than your expectation of yourself. I really expect you to be a scholar. I expect you to have enough confidence in your intellect that when you see something once, you can repeat it. Okay?
Here you go.
There you go. Now, as I said, when I see that among most or all of the students, I will shut my mouth. But when I see you consistently look like you just don't belong here because your mind ain't really into what the objective of this lab is, which is to train you to think and act like a young scientist in training. Not a person taking a class to get a grade, but this is your training because people purify proteins using these procedures. So you see, it's moist. I just let enough buffer for it to be moist. That's all right. Okay. I'm almost done. Okay, it's 9:39. I'm almost done. It's moist. You can see it. But I guarantee you, some of you are going to ask, now she's about to dump my column out because you don't want to treat a column like this and dump stuff out, okay? It's been bored. Okay. But I guarantee you, okay? So you can see that's the height, okay? All right, now I'm going to set the column back up. Okay, now I'm setting the column back up. Okay? And you now want to take one of your things here, and you've got the protein, and you want to put approximately no more than 3 mils on this column. Okay, so I'm going to take approximately 3 mils here, and I'm going to overlay it. Okay, and once I do it this way, okay, now I've overlaid my protein. Okay, now you want this protein to go into the resin before you put no salt buffer on it. So in this case here, I'm going to open the stopcock, and I'm going to let this protein go into the resin. Because if you put buffer on top of that, you dilute your sample and won't work. Okay? There you go. Oh, look at that. Isn't that beautiful? And I just love science. And it's just, science is great. Okay? There we go. So now, I'm going to pass my column around again. I have allowed my protein to go into my column. So you see it. Hey, 30 years of seeing this. Okay?
Dr. Ball, I have a question. Say if you were doing like research and your protein wasn't, like you know how ours is the reddish color from the rat?
Well, it's a reddish color for a reason.
But I'm saying, what if we had a clear protein we weren't able to see once
Well, you can see it. Whether it's clear or not, it's liquid. This is clear. I can determine when this goes into a
But I'm
column.
saying, as it goes through resin B,
Yeah, you won't be able to see it.
that's what I'm saying. So
You won't be able to see it go through.
So what do
You collect fractions. And how do you know when you have proteins? I'm going to show you in a minute. How do you know when you have a protein? Well, we use a spectrophotometer at 280 and we analyze each fraction. That's what you're doing. Not all proteins. That particular protein, okay, is red because, again, it's rat serum. So it obviously has some what in it? No, it ain't got blood in it.
Right.
It has hemoglobin in it.
Oh.
And hemoglobin is a protein that you've been studying, and it has an iron molecule in it. And the reason why your blood is red is because of the iron. Okay? So this has some hemoglobin in it, but it also has the enzyme that we've been studying for the past 13 weeks. I tell you, I love talking science, I love smiling. Okay? I hate excuses, I hate laziness, I hate people that are excuse makers, because excuses don't change anything. Oh, I got an F because I wasn't feeling good. Well, you got an F. Ain't gonna change anything. Did you feel better? Oh, I got an F because I was depressed. Well, you're depressed. Did you take your meds? Feel any better? You don't change anything. Okay? You don't ever want to be an excuse maker. You don't want to be a try maker. Oh, I tried. No, you don't need a try maker. You don't get paid for trying. You want to be a do baby, not a try baby. Do baby, do baby. Hey, baby. Do baby, do baby. Hey, hey. Obviously, I'm feeling the holidays coming in. All right, so now that I have my sample, it's embedded, I will want to take some no salt buffer, okay, and essentially fill up the column and then start, okay, and I'll talk about that in a minute. So let me fill up the column, make sure that your resin clamp is clamped so that it doesn't leak out. And you're going to fill up the column slowly, okay, like so. Okay, and you're just going to, this is no salt, I'm reading it. There you go. Okay. All right, I got some time there. Okay, there we go. There you go. Okay. And I'm just going to fill this all the way up with no salt buffer. Now, of course, okay, I'm going to talk a little bit about collecting fractions. Okay. See now? My timer here has said I've been doing this for like 30 minutes now. Okay. 30 minutes. Okay, so now I have, okay, fill the column up. Now, what you want to do when you create a baseline, okay, so your application. So, again, we've got a Y here. We're going to be measuring absorbance at 280 nanometers, and we're going to start collecting fractions. You have 40 tubes there, okay, so yours goes from 0 to about 40, okay? And what you should do is fill in the first 5 tubes. Fill in the first 5 tubes with no salt buffer. And that's going to be used as your blank, one of them. And so it gives you a baseline. And then as you start collecting fractions, if your protein comes off, the spectrophotometer will read it, and it should go back down, okay? And it should go back down to less than 0.1 absorbance, okay? And then once you add the salt, we're going to point in time where you're going to now add the salt, then essentially another peak will come off. So I'm going to do that, but before I do that, the procedure says that you need to collect 5 ml fractions. So, what you then should do, okay, I mean, you're good, is you take your 1 milliliter pipette, and you take the first tube and you pipette 5 mils. There's 1, there's 2, there's 3, there's 4, okay, go. And there's 5. Okay? So I have 5 mils. Now I can take my marker and I can mark that tube where it gives me an idea where 5 mils is. Okay, and now I can pour that buffer back in there. And now I can just take some time, lay my tube down, take one tube, put it next to it, put a mark on it. Put it back in there. Take another tube, put a mark on it, put it back in there. Take another tube, put a mark on it, put it back in there. And I do this all 42 because it then allows me to determine 5 mils in each tube. So it allows me to mark and so forth. All right, so now I'm ready to start collecting fractions. So what I'm going to do again, now that I know what 5 mils is, okay, I'll take 5 mils, okay, and I'll put it in each tube here, the first 5 tubes as my base, okay, okay, and so you get a chance to see me do that, okay, there we go. There's test tube number 3. Okay, there we go. So I'll take the tube, and again, take another tube and mark. Okay, mark, there we go. Take another tube, mark it. Okay, that allows me to, okay, let me see again. This guy here.
I got it.
Why, thank you very much, Madame. Appreciate it. Okay. And I'll take another tube and mark it and so forth. Okay. All right. So I'm going to mark maybe 10 tubes. Okay. And then you can see that it doesn't take a whole lot of time at all. Okay. You have until the 1st of December. Turn everything in. You have all week long to finish something here that takes approximately 1.5 hours. 1.5 hours max, if that. I've been doing this now for 35 minutes. Okay? And I'm ready to collect fractions after 35 minutes. Okay? That's why I say, realistically, when you think about all of the excuses that you give for not being efficient and effective, that's all they are. It's just a bunch of excuses. I piss some of you off because I don't accept your excuses. But again, I'm not here to make certain you don't piss off or write anything bad about me. I'm here to train you to think like a young scientist in training. That's why I'm here. All right, so now that I put, okay, let me put my 5 mils there. Okay, I've got tube number 4. Okay, there we go. And it doesn't have to be perfect, okay? You don't have to be perfect. Get it, okay, so forth. All right. So now I open up, here's my first tube after 5 mls, tube number 6. And I open up the stopcock, and now I'm going to collect fractions. Okay, I'm just collecting fractions. And if I wanted to determine the flow rate, I could actually time to see how long it took me to collect 5 mils. And then I could divide 5 mils by whatever time it took me, and that gives me the flow rate of how my column is flowing. You don't want your column to flow very fast because the interaction is not covalent. It's ionic. And if you flow too fast, then essentially you push proteins off that shouldn't be there. Okay. There we go. Then all I have to do is just stop that guy. pick up another tube, open this guy up, collect fractions. Now, of course, the proteins that are coming off, that are in the first fractions at this given pH, they obviously are positively charged because they're being repelled by the resin. And those proteins that have an overall net charge that's negative at this pH will bind. And then you have to use the salt buffer to get it off. Okay? I mean, you guys are very smart, but for some reason, and I'm sorry, you've just been cheated a little bit. I wasn't cheated in college. I got my money's worth, okay? I didn't have to spend another dime. I didn't have to take no post-bac program. Hey, I took the MCAT to say, I'm gonna kick its butt. Okay? Now I'm just collecting fractions, and you can see that. Okay? So you can imagine I was a little bit weird person in the 70s. Can you imagine that? Okay. Yep, real weird in the 70s. Okay. Anybody know where Roanoke College is? Hmm? Roanoke College. No, it's not. No, it's not in Roanoke, okay? It's in Salem, Virginia. It was established in 1845, I believe. Roanoke College is called the Little UVA. You know why it's called the Little UVA? Because the average SAT scores of the students there are 3,000 students, is 1,400 out of 1,600. A lot of smart people went to that school. This is a school who its president, okay, and former alumni, is president of the Norfolk rail system here. Okay. So all that I'm saying to you is you made the right decision coming to Norfolk State. And the reason you made the right decision is because we are committed to getting you ready to compete. The problem is that you're not ready to compete. That's the problem. You're not ready to compete. You still are looking for a path of least resistance. Okay? Maybe I'll get into medical school with a 3.0. No, you won't. Maybe I'll get into medical school if I don't do well in the MCAT. No, you won't. Maybe I'll get this job if I don't know how to do anything. No, you won't. Okay? And what will happen? You'll be embarrassed. I will go to Walmart, do shopping, and I'll see you at the produce section. That has happened. That happened. I saw a chemistry major at the produce section in Walmart in Virginia Beach Boulevard. And he tried to hide, but he couldn't hide. He saw me coming. Okay? And I told him, don't be embarrassed. Okay? But I told him he was not going to get a job as a chemist if he didn't understand and know his chemistry. And he didn't believe it. Okay? So, all right, ladies and gents, so you see, that's how I collect fractions. And I will continue to collect fractions, okay, for about the first 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15. 15 tubes. And then I will measure to see the absorbance. And if I see a peak, then I know that I'm there, and then I'll continue collecting fractions until the peak comes down, okay? Until the peak comes down here. And when it gets to less than 0.1, I know that there's no more protein coming off. And then I will essentially start the salt buffer. Okay? So I'm going to do that when I return. So now you can set up your column. Okay? Now again, it took me 43 minutes to go from step 1 to step 3 step 4 where I'm actually collecting fractions here. Okay, so get going. I'll peek back in you in a little bit. Okay. Got everything you need? I told you from start to finish. Okay.